multiplying the exponent to the base. Hopefully, wherever you still have issue, will clear up today. All right, quotient property. Again, we've already done this, dividing like bases. And again, don't misappropriate the exponent. In this one, you still have the C on the top. You still have the D on the bottom. And then you're simply doing x to the a over x to the b equals x to the a minus b. It's the most simplistic way to do the problem. Now this is exactly the same as c over d times x to the a minus b. But again, that's unsimplified, isn't it? Look, if you want to, don't write this, if you want to write it like this, isn't that really unsimplified? Because it's, again, it's a fraction times a fraction, top times top, that's a minus, sorry. Top times top, bottom times bottom. So again, just do it as one. It's the same principle of, would you, if you had the answer of 6, would you then make it 2 times 3? You wouldn't. So just leave it in the most simplified form. But I will take it the other way, but that's so much easier. All right, again, you need to ask questions as I go. So I'm going to go quickly here. So A is just a simplistic rule, right? A is going to be, Earth to people, A is going to be n to the 7th, right? Because again, we're doing 10 minus 3 and we're getting n to the 7th. All right. With B now, be careful. Don't misappropriate the exponent. Oh, excuse me. So hopefully right away you know you're going to have a negative result, right? Because a negative divided by a positive is a negative. And you're looking to reduce. And I'm just looking for common factors. I'm going to do negative 5 times 4, and I'm going to do 2 times 4, right? I'm just reducing. Those numbers are coefficients. They're multipliers. The variables, the exponents don't apply to them. I divide out the common 4s. I know my top has a negative 5 in it. I know my bottom has a 2 in it. And then everybody think about this one. I want you to give me what this part is. What is an x to the 7th divided by x? Hold on a second. So x to the 7th divided by x. So on 3, give me what you think that is. Here we go. 1, 2, 3. X to the 6th, right? Because again, we don't show the 1s. 7 of them minus 1 of them is 6 of them. And again, one more time, this is a shortcut. What is an, don't write this, what is an x to the 7th over an x? The x to the 7th is just like an x to the 6th times x. Isn't that an x to the 7th on the top? And the bottom, and you divide out the common x's, and what do you get? X to the 6th. I mean, remember, the rules are shortcuts to taking care of these things. So if you had 7 of them in the top and 1 of them in the bottom, the 1 in the bottom, the 1x in the bottom wipes out 1 of the 7 in the top, and it leaves you 6 on the top. That's all you need to think. If you can get to thinking that way, you'll be in better shape. All right, so C, obviously you got to put it into the other format, right? So if I were doing this problem, the first thing I would do, thank you, Windows 10, appreciate your ministry, right? I would write it this way. It's the first thing I would do. So is your answer going to be positive or negative? And the number part is going to be, so a negative 2, right? Because you just got done telling me it's going to be negative. I hope we can all do negative 10 divided by 5. That one divides in evenly, so we don't have a number on the bottom, right? We just did 10 divided by 5. What's a cubed divided by a squared? Look, you got 3 on the top, you got 2 on the bottom. 2 on the bottom, wipe out 2 of the 3 on the top, you got 1 left on the top. Or you can think of a to the 3 minus 2 if you want. but it doesn't have to even be that difficult. And if you have b to the fourth and b on the top and b squared on the bottom, you end up with b squared, because 2 of the bottom ones wipe out 2 of the top 4, and that leaves you 2. Or again, 4 minus 2, and either way you get there. But you got to start understanding, all we're really doing with this rule is shortcut to factoring and reducing by factoring. It's all we're doing. But when the variables start to get big, if you'll just think of it that way, it goes a lot more quickly. So when you get to a problem like this on the quiz, let me get rid of this stuff. So, you know what, I'll save. I'll come back to that once we deal with negative exponents one more time. And I'll just show you how to deal with them top and bottom, and hopefully do them quickly. All right, so negative exponents. Again, I don't know why you guys make these difficult. But you do, because students don't see it as clearly for some reason. It's just the way your brain works. But the negative with the exponent says to take the base with its exponent and do that in the denominator. What is the shortcut to this? If I take the base and its exponent across the fraction bar, this is top, this is bottom. I change the sign of the exponent. Went from negative in the top to being a positive in the bottom. That's the shortcut. Whenever you take a base and its exponent across the fraction bar, either way, bottom to top or top to bottom, it changes the sign. That's all there is to it. So in the second example, I got the negative in the bottom, so take the base and its exponent across the fraction bar, and it's positive in the top. And that's all there is to it. Now, if you want to be technical, you can put this in your notes or not. I really don't care. But here's technically, let me go back and get black. Here's technically how you get there. Let's go back to the original. And let's now, again, if you want to, don't circle that, but here's where I'm at right now, right? I'm doing the 1 over x to the negative a. If you want to look at this as the previous left rule, then that's where you're at right now. Right? Again, just forget about the top 1. Just think about x to the negative a, right? What is it? 1 over x to the a. 1 over x to the a. Now, this is true. But we don't leave things with a fraction in the denominator, do we? Do you ever see an answer like 7 over 3/8? Well, you can't leave your answer like that. You have to further simplify your answer. How do you simplify this? Well, in the denominator, you want to get a 1. So I'm going to multiply by x to the a over 1. But whatever I do to the bottom, I have to do the same thing to the top. So on the bottom, what happens? The x to the a's divide out, and what are you left with? X to the a in the top. So that's the math of how it happened. So again, this negative does say do 1 over x to the a, but when you simplify it, it ends up with the x to the a in the top. So what does the rule do? It saves you worrying about all this stuff. It just basically tells you this. Change the sign of the exponent when taking the base and its exponent across the fraction bar. That's all you need to do. Change the sign of the exponent when taking the base and its exponent across the fraction bar. All you need to do. That's all you do. And again, you guys need to ask questions if you're not understanding. I've been doing these for 30 years and I understand them perfectly. And you've only been doing them for 2 years and you might not. Raquel, go ahead. Okay, so A is pretty straightforward, right? A is the rule, so hopefully you agree. You're going to have 1 over 7 squared. And we should simplify our answer, right? So this is 1/49. So B is 1 over 3 to the negative 3. So class, what's B going to equal? Speak up. 3 cubed, and then we're going to further simplify that, right? We're not going to leave it 3 cubed. We're going to end up at 3 times 3 is 9, times 3 is 27, and we're going to get 27, right? Okay, so that's just, those are straightforward. The only thing involved is the base and the variable, right? You got the base with a negative variable in the numerator on the left for A, the base with a negative exponent in the denominator on B. All right, look at C. Don't misappropriate the exponent. Does the negative 4 exponent have anything to do with the 3? And the answer is no. It doesn't. So, again, look, this is how I would do these problems. Negative exponents in the top become positive in the bottom. Done. 3 over x to the 4th. That's it. I took it across the fraction bar and I changed the sign. Done. End of problem. So how would you simplify D? How would you simplify D? Just take the y to the negative 2 across the fraction bar and stick it in the top. Done. 5y squared over 2z. There's nothing else that gets involved with that one. All right, E's got a little trick to it, and that's why I chose it to show it to you. There's a couple different ways you could do E, but here's the easiest way to do E. And again, I see no hands, so I'm assuming everybody knows what's going on, and therefore I'm rolling on. The best way to do E, or the easiest way for you guys, is you apply the exponent to both the top and the bottom. So a parentheses 4/3 to the negative 2 means the 4 is to the negative 2 and the 3 is to the negative 2. The top gets the exponent and the bottom gets the exponent. You guys follow that? Okay, now just do what we did a minute ago. Stick the 4 squared downstairs, right? And stick the 3 squared upstairs, right? Because we're getting rid of the negative exponents. Take the base with its exponent across the fraction bar and change the sign. Okay, we got to finish off because these are numbers, right? And this is just 9/16. Can you handle that? Let's do some compound problems. Okay. Let's use our color on this one. If you got a 3 on the top and the 15 on the bottom, do you agree you're going to have a 5 on the bottom? I just reduced the 3 and the 15, right? If you got a 3 on the top and a 15 on the bottom, because a 15 is a 3 times 5, and the 3's divide out, right? 5 on the bottom. Again, if you don't understand what I'm doing, you need to ask questions. I'll show it to you more fully. Raquel. Because 15 is a 3 times 5, and 3 divided by 3 is 1, leaving you a 5 in the bottom. Just reducing. I'm going to use my green. Let's do the x's. If you have 5 x's in the top and 2 in the bottom, how many of that does it leave you, and where does it leave you? We're going to have x cubed where, in the top or the bottom? In the top, because there's more in the top than the bottom. 2 of them in the bottom, wipe out 2 of them in the top, leaving you 3 of them in the top. If you can't think that way, which I don't know why you can't, but if you can't, then do the rule. X to the 5 minus 2 leaves you x to the 3. But it's a whole lot easier if you can think that way, because let's do the last one in blue. If you have a y cubed in the top and a y to the 7th in the bottom, that leaves you how many y's, and where does it leave you then? In the top or the bottom? Because remember, we're never supposed to have negative exponents. So it's going to leave you how many y's? Y to the, in the top or bottom? In the bottom. Because 3 of these wipe out 3 of these, leaving you 4. And we're just doing, this is, again, just a shortcut. Because what is a y to the 7th? Y cubed times y to the 4th, and the y cubes wipe each other out. That's it. Problem's done. You can clean it up and finalize your answer as x cubed over 5y to the 4th. Done. Rolling on. Oh my. Oh my. Okay, let's simplify first so we're clear. The negative 2 is outside, so that exponent has nothing to do with it. Do you agree? However, that negative 2 goes to every variable now. Kaylin, question? Wouldn't it be what? If you do a negative 4, it would be negative 4 in the top. What's 3 minus 7? Negative 4. The negative 4 would be on top. But Kaylin, here's really what we're doing. All right, so let me show you in a nutshell. Let's get rid of that. What is y to the 7th? Y cubed times y to the 4th. Do you agree with that? Kaylin, what is y cubed divided by y cubed? 1. Is that a negative 4 in the bottom, or is that a positive 4? That's why we wrote positive 4. Because the 3 in the top wiped out 3 of the 7 in the bottom, and there's 4 left in the bottom. That's all we're doing. That's all we're doing. Wherever the most is, if they're both positive, then you're going to have that amount in that numerator or denominator, wherever the most are. So watch, that'll come into play again here. We end up with the negative 2. What's x squared to the negative 2? X to the negative 4, right? What's y cubed to the negative 2? Y to the negative 6, right? And all over 8x. So all I did first was exponents, right? And now it's a division problem. All right. Windows. A negative 2 on the top and an 8 on the bottom. Leaves you a negative on the top and a 4 on the bottom, right? You can all do a negative 1/4. You can write the 1 if it makes you feel happy. Let's do our x's in green. X to the negative 4 in the top gives you how many x's in the bottom? 4 of them in the bottom. You already have 1 in the bottom. How many total x's in the bottom? These 4 go to the bottom. You already had 1. Now you got 5 in the bottom. Again, if you were going to do it long way, x to the 4 in the bottom times x to the 1, x to the 4 plus 1, x to the 5. But again, negative 4 in the top is a positive 4 in the bottom. 4 of them and 1 of them is 5 of them. And what are you going to do with your y's? You're not going to leave them negative in the top. You're going to stick them in the bottom, right? So this thing ends up, we actually need that 1. Negative 1, 4, x to the 5th, y to the 6th. And that's it. Try not to make these hard. They're not supposed to be. You're just moving stuff and combining how many you have of them. And it's all a multiplication problem. No addition going on. Look, in this one, would you agree that would be true? So what do you end up with? A squared, right? What's a negative 5 of them and a positive 7 of them? 2 of them. If you feel better and you want to do this, okay, what do the 5 in the bottom do to the 7 in the top? Wipe out 5 of them. How many are left in the top? 2 of them. If your brain thinks better, switching them both, switch them both. Look at D. Now again, I would just do this, but isn't this where you're going to end up? Therefore, what's your final answer going to be on this one? 1 over n to the 14th. The n's are in the bottom, right? Don't make that mistake. Do I have numbers written? I do. Okay, good. All right, work on that. Get your rules down. Get your rules down. Get it figured out tonight. Get it figured out tonight. Get it figured out tonight.